Hello everyone, hope you all are having a good day. This is Soham from SNS Learning and wishing you hassle-free learning ahead. So in today's video, we are going to learn about different normal forms and how these normal forms are actually applied in relational database to minimize the data redundancy and the anomaly problem. So as you can see in the screen, this is a roadmap, a brief roadmap of how we are going to learn each and everything today. So first we will explore on a lighter note what is normalization. Then we will go to various types of normal forms, their definitions, and then we will cover the actual process of applying those normal forms into database tables. So let's get started and explore one by one. So what is normalization? Normalization is is a technique which eliminates or which reduces the data redundancy problem and the anomaly problem, the three anomaly problem, which is insertion, deletion and updation anomaly problem in a relation. So if you are not aware of what is data redundancy problem and the anomaly problem, you can go and check out my first video in this series. I'll provide the link later in the video. So this is in general normalization is. Now we will go and check different normalization. The first one is, there are mainly three normal forms. There are other normal forms also, but I'm not going to cover this in this series. We will take it on a next tutorial. So we'll cover these three normal forms. So the first one is 1NF or first normal form. This is the most simple one to achieve. So if you go by the definition, it states that the domain of an attribute in a relation must be atomic. Domain means nothing but the values of an attribute. So all the values are called domain of that particular attribute, or in a table that particular column. So I think it would be easier if you can parallelly see the actual scenario. So for 1NF, I am considering this table, which is the employee table. Employee number, employee name, employee gender, and employee contact number is there. So all employee related information is there, and it is a very common table. If you see the data, every employee is associated with contact number. Now if you see this row, employee Philip is having multiple phone number. This is very common. One can have one primary contact number and the other is, you can say, a secondary contact number. Now as the definition says that every attribute or every domain of every attribute should be atomic. Atomic means it will not allow multiple values. Now why I am saying it multiple values? Because I am accommodating two contact number in one cell, and this is violating the 1NF. Now, to make it 1NF compliant, I have to anyway make this cell containing single value and also ensure that no data loss is there. It is not that I'm deleting one phone number and making it 1NF compliant. No, I have to keep this information as well. Now, let us go to the solution to see how we can achieve this. Let me click on it. So yes, there are multiple ways to achieve and make it 1NF compliant. Let us go one by one. If you see the first possible solution, what I've done is I have splitted this column employee contact number into two columns. One is, you can say, one is for the primary contact number, one is for the secondary contact number, and thus I am accommodating each attribute one single value. So my problem has been solved. Now Philip, I can say that Philip is having multiple phone numbers, and I am populating or I'm accommodating it as a single value in each attributes domain. But it has some serious drawbacks also, and I think you have already got that. If you see the highlighted rows, these I had to populate this with null because I do not have any information on whether Brian, Chris, Lauren or Ginny has secondary contact number or not. Because it is null, it is not updated yet, and I have to populate it with null. No other way. Now, as you all know, that introducing null values is not a good design practice. It will complicate things later when we will retrieve relations based on some other relations, or you can say when we link this relation with some other relation to retrieve some more detailed information, it will not behave the way we will expect. This is number one drawback. Number two is, if you see, I have splitted this into two columns. Now let's say in future Brian will have, say, 3 phone number. It is possible that Brian will be having 3 phone number. Now to accommodate that, first of all, I cannot accommodate this scenario in this table because I have splitted this into assuming that every employee can be having maximum of 2 phone numbers. So the second drawback is, to make this design, I have to know prior to the data loading what is the maximum number of phone number that an employee can have. So you can easily understand the two major drawbacks of this design. So in real life scenario, this design is not accepted, but it is one of the possible ways to have it 1NF compliant. Anyway, let's go to the second possible way. This is the most simple way. I have created 2 records, each having 1 contact number. So if you see these 2 records, Philip is, I can say from this table that yes, Philip has multiple phone number, and for that I have to make 2 records of Philip. Now this is also comes with a major drawback. This is also related with data redundancy. What is that? Now to make it 1NF, I have to repeat this information, right? So just to make this employee contact number column to be in compliant with the 1NF definition, I am repeating this information, which is nothing but a redundant information for anyone. So this is also not a very good design, and this is in generally not accepted in real life relational database design. Now come to the last and the most accepted and the most proper way of making our table 1NF compliant. See, what I've done is I have created one new relation or a new table where I have kept these 2 column, employee number and its associated contact number. Now if you see here also, I am repeating these 2 information, like repeating this employee number 302 times, so that its associated contact number is 1NF compliant, or every on the domain of this employee contact number is atomic. But if you see here, I have only repeated these employee number column instead of repeating these 3 columns all together. And another thing to be noted is that I have made employee number and employee contact number both as primary key. So it's a composite primary key, so that I can easily identify by looking at these 2 combination I can uniquely identify each and every record for this relational table. So in summary, to make it 1NF without introducing redundancy of data further, I am creating one additional relation out of this relation, which is comprises of employee number and employee contact number, and this relation will look like employee name and employee gender column. This will be one of the relation and this is the other relation. So I'm splitting the relation altogether to make it 1NF compliant. Now we'll see what is 2NF. So if we see the definition, it says that relational schema R is in 2NF if it qualifies 1NF and every non-prime attribute A in R is fully functionally dependent on the primary key of R. Okay, we'll go and see the actual scenario, then we'll come to this definition again. Consider this relation. It's an employee project table where relation about employee and its assigned project and the number of hours he or she has invested in that project is recorded. And the primary key of this relation or this table is employee number and project number. So if you see, these are all unique values and you can easily identify uniquely through these two columns or these two attributes. So these are the non-primary attributes. To make this table 2NF compliant, first we have to ensure that yes, it is 1NF compliant. And if you see, it is definitely 1NF compliant because no domain of attribute is containing non-atomic values. Every domain of every attribute is containing atomic values. So it is 1NF compliant. So the first condition satisfies. Second condition is no non-prime attribute, means these are non-prime attributes. So these no non-prime attributes should be partially dependent on the primary key. Now see it carefully. These four attributes are non-prime attributes, means these are not part of primary key. These two attributes constitutes primary key. So these are all part of primary key, and these two combines creates the primary key of this relational table. So now we will see one by one of these non-primary attributes, their dependency. Now hours worked, I can say that hours worked is fully dependent on these two columns. Why I'm saying that? See, if I know the employee number and the project he is working on, I can easily say that this employee has spent 16 hours of time in project number 10, or this employee has spent 24 hours in project number 20, right? So I can say that if I am given employee number and project number, I can easily identify the amount of hour that the employee has worked on a particular project. So this is fully dependent. Now come to employee name. Employee name is fully dependent on employee number, but it is not dependent on project number. Why I'm saying that? If I am given an employee number, I can easily retrieve or I can easily identify its associated employee name. But if I am given only project number, seeing only the project number, I cannot uniquely determine its employee name. Let's take an example right now. Say someone gives you project number 10 and asks you find out the employee name associated with this project. Only seeing the project number, you can't see the employee number column. See, if I'm giving the project number, if you see 10, say I'm giving you project number 10, so you will have two employee. 10 corresponds to Brian, 10 corresponds to Phillips as well. So it is not accurate. But if I'm giving you 100, you can easily say that yes, 100 corresponds to employee name. Though if you see two records are there, but they are inconsistent. Like 100 always refers to Brian, 200 always refers to Phillips, like this way. So in summary, I can say that employee name is dependent on employee number but not in project number. So what we can conclude this is employee name is not fully dependent on the primary key of this table, because the primary key of this table is these two columns. So in this scenario, you have to split this relation into another relation so that every non-prime attribute, employee, for example employee name, will be dependent on employee number. Now come to project name. It's the same as employee name. Project name can be determined by project number, or it is fully dependent on project number but not on employee number. I cannot determine a project name by only seeing the employee number. Same with the project location. Project location is dependent on project number, but it is not dependent on employee number. So project name and project location also have a partial dependency on this primary key. Now we have to make this table so that every non-primary attribute is fully dependent on its primary key. Let's come to the solution. So this is the solution. I have to make 3 different relations so that it will be 2NF compliant. See, employee name is fully dependent on employee number. Employee name is dependent on employee number. So I have created this one. Here primary key is employee number, non-primary key is employee name. So it is in compliance with 2NF. Now come to the second relation. As we saw that project name and project location is fully dependent on project number, right? So we have created this relation so that it becomes 2NF compliant. Project name and project location here is non-prime attribute and project number here is the primary key. So every non-prime attribute is fully dependent on this primary key. The same goes for employee number, project number. The same goes for this hours worked attribute, because it is non-primary attribute. So we saw that hours worked can be determined considering both employee number and project number. So this is the relation. Here if you see, hours worked is a non-primary attribute and employee number and project number is primary attribute. So hours worked is fully dependent on this primary key. So it is 2NF compliant. Now it is up to you how you will come to the solution of making a table 2NF compliant. Now what I have seen, the most easiest way is just one by one go all the non-primary attributes and see their dependency on dependency on the primary key. Just like I have also done the same way. First I have analyzed what is the dependency of hours worked to the primary key. Then I had analyzed what is the dependency of employee name, then project name, so on. So it would be very easier to understand or get an idea how I can split the table so that it becomes 2NF compliant. Now coming to the third normal form. Now third normal form says that a relational schema R is in 3NF if it qualifies 2NF and no non-prime attribute of R is transitively dependent on the primary key of R. Now what is transitive dependency? First we have to understand this. Then the 3NF is basically almost same as 2NF. Now transitive dependency means it's a classification of dependency, you can say. The dependency that we have just seen here, like hours worked or the employee name, is dependent on project number, like this one. Like project location and project name is dependent on project number. So transitive dependency is a kind of dependency. Now how? Let us understand with a example here. Say I have a table where employee number is there, employee name is there, employee address is there, and employee zip code is there. Consider this as another employee table. Now see, and say this is the primary key of this table. So these are all non-primary attributes. Now if you see, employee name is obviously dependent on employee number, employee address is obviously dependent on employee number, employee zip code also is fully dependent on employee number. Means given an employee number, I can uniquely identify its employee name, employee address and employee zip code, which is fine. If you look at more carefully, employee zip code is dependent on employee address, because if given an address, I can find out its zip code You're getting it right. Means these three columns, these three non-prime attributes is dependent on employee number. And this is another non-prime attribute which is dependent on another non-prime attribute which is employee address. This is called transitive dependency. If you mark it as A, if you mark it as B, and if you mark it as C, then in technical term you can say A B, then B, C. It means that B can be functionally determined by A, means employee address can be functionally determined by employee number, and C means employee zip code can be functionally determined by employee address, and B should not be a primary key. So if you see this kind of scenario, you have to split that table so that these kind of dependency is eliminated. Now let us come to actual scenario, then it will be easy to digest. So this is the table where employee information, its associated department number, and the department's manager number is given. So for example, Brian is an employee who is working with department number 10, and Philip is managing department number 10. See it carefully. Department number is that kind of column. Say, I can easily determine department number if I'm given this employee number. Means, given an employee number, I can uniquely identify which department this employee is assigned to or is working on. In the same way, given a department number, I can say who is managing this department. So in the same way, if I mark it as A, if I mark it this department as B, and if I mark department manager as C, this relation holds. B is functionally determined by employee number, and C is functionally determined by department number, right? And this department number is not part of a primary key, so break it. What I've done is I have taken this part out here so that every non-primary attribute now fully dependent on employee number, and I have taken out this part of table with this one. So every non-primary attribute now becomes fully dependent on this department number. Why I'm saying this? Because see, department number 10 manages by Philip. 20 is managed by Michelle, etc. Now see another interesting thing here. It's a perfect example of data redundancy elimination. See here, I have two department number and two manager, but to represent this with this relation, I needed 3 records. Now I'm conveying the same information with 2 records. So this is a perfect example of data redundancy elimination. So now go back to the definition. So definition says a relational schema R is in 3NF if it qualifies 2NF and no non-prime attribute of R is transitively dependent on the primary key of R. I think you are getting it right now, because these was the transitive dependency. We have eliminated this, and this is completely 2NF compliant because every non-prime attribute is dependent on their respective primary key, and also it is compliant with 1NF because no attributes domain contain non-atomic values. So thanks for watching.